This is Sakshi back, and I welcome you all to my analytic platform, Way to Learn. So, we are going to we are going to see how to remember Maxwell's equation with the trick that I have told you in my last three videos. So, if you are new, please check my last three videos and then come back to this video so that it will be like you will get clarified with the tricks and how to use them. Okay, so let us see the Maxwell's equations. So these are the Maxwell's equation used in thermodynamics, and we are going to derive these Maxwell's equation from the trick. And the trick is the great physicists have studied under very fine teachers, right? So basically we write that as great physicists have studied under very fine teachers, right? So what I've done is I've taken these corner terms alone. P, T and SP. Okay, that is what you have to do in order to derive the Maxwell's equation now. Okay, so now let us see. Okay, let us see how to derive this Maxwell's equation. Okay, so if I move from V to T, then similarly I'll have to move from S to P. Okay, so if I move from V to T, then I'm going to write it as dou V by dou T. Okay. See, I'm moving from V to T, so I'm going to write as dou E by dou T. Similarly, I'm going from S to P, so I'm going to write dou S by dou P. Now, the constant terms. So, the opposite to V is P, diagonally opposite. So, it is P. So, dou E by dou T at constant P, right? And now, the opposite to S is T. So, this is a constant T. So, now remember, we are choosing S over here, right? We are going to find the diagonal opposite to S. So we know that S, wherever we are going to use S and P, we have to use a negative sign, right? So here I am going to use a negative sign. Okay. So next we have to find the second relation. In my first relation I have gone from here to here. So in my next relation I am going to move like a square. Here to here. So if I'm moving from T to P, then I have to move from D to S. So from T to P, I can write dou T by dou P. And similarly, from V to S, I can write dou V by dou S. Now we have to see the opposite diagonal for the constants. So the opposite diagonal of V to P is P. So this is the constant T, and from the opposite diagonal of T will be S. So this is the constant term. Okay, so let us see our next Maxwell equation, which is going from this side to this side again. So I can write the equation from P to S, dou P by dou S. Similarly, dou T by dou V. So for P to S, the opposite to P will be V. So now remember, I am taking P and I am going to choose the opposite diagonal of P. So I have chosen P here. So we'll add a negative sign over here. Similarly, for dou T to dou V, the opposite to T will be yes. This is the third Maxwell's relation. So let us see the fourth Maxwell's relation, where I'll have to go like this. Then I'll have to also go from this to this. Okay. So while I move from S to V, I can write dou S by dou V. And here, dou P by dou T. So I'm moving from S to T, that is S to V. So opposite to S will be T, and since I'm choosing the opposite of S, a negative sign over here. Similarly, the opposite of T, so again a negative sign over here. and the opposite is b. So this negative and negative will cancel each other. So this is the Maxwell equation, fourth Maxwell equation. So I hope you understood this trick. Okay, so we are just moving like a square. Okay, so I hope you get this, and please try this on your own so that you can get a command on these formulas. So if you make a formula notebook and write all these formulas on your formula notebook, then when you solve the problems, it is going to be very much helpful for you. So I hope you found something useful in this video. So thank you. Like my videos, share my videos if you like them, subscribe my channel, and do not forget to hit the bell. Only when you hit the bell, you're going to get my notifications of further videos. So see you tomorrow. Ta-da!